in this short video, I'm going to bring out key points about activation functions. And there are two important functions the activation functions helps us with. One is, when we are moving from left to right, from input to the output, called the feed forward mechanism. It will help us to regulate the sum product of inputs and weights, okay, to a quantity, regulate the quantity, or bound the quantity closer to a decision rule like yes or no, or bound it to a meaningful range. Make sure that it will always have the output to be between 0 and only positive values, or values in some other bounded range. Positive values means it can go up to infinity, right? So all those things are made possible by the transfer function, also called activation function. There is another purpose that activation function will help us. That is when we back propagate the errors, because our purpose is to reduce the loss function to minimum point. So whatever the error that happens in the loss function, if we want to reduce it systematically, you want to look at the weights that you estimated and change specific weights in a specific way. In what way? In the direction of the movement of reducing the errors, reducing the loss, or reducing the errors. In the direction of reducing the errors. So back propagation, during the back propagation process, the activation function helps us to determine how to distribute the loss function errors to the weights, so that in the next feed forward we are assured of reduced loss. Okay, so that those two purposes are achieved by loss function, and it's very important. Okay, and that's what helps us in actually creating a wonderful neural network solution that works. Okay, but there are many activation functions that one can use, and now I'm going to quickly discuss those important activation functions. Sigmoid activation function is one of them. Sigmoid is the logistic function, and the logistic function takes the input from minus infinity to plus infinity, and then transforms that between 0 and 1. So whatever the sum product is, negative or positive, it will map it between 0 and 1. And if it is closer to 0, that means it's useful for yes or no type modeling, right? The qualitative modeling or classification modeling, yes or no, 0 or 1, cat or dog, like that. So so the lowest values, when it is closer to 0, then it's class 1, cat. If it is closer to 1, after the activation function is applied, closer to 1, it is dogs, like that. Okay, so it helps us to make that kind of 0-1 decision, yes or no type decision. And I want to get your attention on the derivative also. Remember, because the derivative is the one that tells you in which direction you have to distribute the errors to the weights. In other words, you have to distribute the errors in such a way that the weights are influenced in the back propagation step, so that the errors are reduced in the following feed forward step. Okay, so so the direction in which you have to move or distribute the errors in such a way that the weights will move to reduce to loss is the gradient direction, okay, of the activation function. That is the benefit I told you earlier, right? So the first derivative is always important, and for every one of the loss function we are going to discuss that one. And interestingly, first derivative is like this. The first derivative of loss function, the sigmoid function is like this. So it's almost like a normal distribution, right? It looks like that beautifully. So which means it has a small changes here, but then big changes after almost between 1 sigma values. It has maximum growth. Quickly it picks up, and then maximum speed is happening here in this area, and then it tapers, and then it reduces. Okay, that is sigmoid activation function. So let's look at the Tanh activation function. The Tanh activation function maps the minus infinity to plus infinity of the sum product values between minus 1 and 1. See, that is the beauty of beauty of the tanh function. In the logistic function or sigmoid function, it is 0 to 1, but here it is minus 1 to 1. Sometimes you want to, apply, you want the output values to come out, the transfer values, activated values to come out between minus 1 and 1, and then you can apply the tanh function. The other function is very simple linear function, so basically, by the way, the logistic function, the tanh function derivative also looks like a, normal distribution, but the idea is that, the logistic function moves very slowly, okay, compared to tanh function. You can see that, between minus 2 and 2, most of the values are, most of the changes are happening. But in the case of, logistic sigmoid function, it takes up to minus 5 to 5, okay. So it's very elongated, slow movement compared to tanh function. But more importantly, if you want the output to be between minus 1 to 1, use tanh function. The next one is linear function, and very simple. If you use the linear function, you are basically mapping whatever the sum product value, as an identity value. That means nothing is happening, but then its derivative is the slope, okay. So whatever the slope value of that particular function you have, the calculated value, the sum product value function has it. It's basically a it's basically a the multivariate plane, okay. So the derivatives are if there are m parameters, if there is only one parameter, then it is the slope, right, slope value. But if there are m parameters, then it will have multiple, it's a vector of slopes, right. So that's a linear function. But what is more important is the next one, what is called rectified linear unit, because oftentimes you don't want negative values to happen. You want to truncate all the negative values to 0 and keep only the positive values. That's the kind of information is mapped by the rectified linear units, and that's why it is, this is the function, but its derivative is, it's always 0, and its derivative is 1 when you have positive values. So remember, this is what your, the back propagation is going to be helped by this function. Remember that, okay. The other one I want to introduce you is that the rectified linear function actually has, it maps all negative values coming out of the sum product to 0 values, and all positive values are just, taken as positive values. Identity transformation after positive, and for all negative values it is, mapping it to 0. That's what it is, okay. And sometimes you don't want that kind of, all negative values to be completely, assigning it to 0, but maybe a small quantity, okay. So that is what is called a leaky ReLU. So it has a small quantity, it is going to minus infinity, but in a very, very slow way, okay, not at the same speed like what the sum product values are. And so the positive is, the identity function is used for all positive sum product values, or product sum product values, and negative values are assigned a very small quantity, okay, very small quantity. And again, the derivative here is that it is 0. It's not 0. It is a small positive value when for all the negative sum product values, and then it is 1 for all the positive values. And the other one I want to introduce you is exponential ReLU, exponential linear unit, not ReLU, exponential linear unit is this function. It looks complicated, but the benefit of this is that it is a very smooth function. It is not like the previous function like this, but it's a very smooth function. Sometimes the smooth functions are very, very useful mathematically. So we use this kind of expression z, for all the positive values it takes identity kind of identity values, same value. For negative values it takes a small fraction times alpha times e power z minus 1, okay. And the derivative is like this, for all positive values it is 1, and for the negative values it is alpha times e power z. So we have a list of a few other activation functions here in this list. I invite you to take a look at it, and always think about the graph and some name that is given, and these are the most important functions. I would bring it up to you: logistic or sigmoid, Tanh function, and rectified linear function, rectified linear units, and their derivatives. Okay, so those are the most important things. Thank you very much.